Okay, now let's look at scientific notation. So scientific notation is used to write really, really big numbers or really, really small numbers. The format of scientific notation is we write it as some number multiplied by 10 to the power of some integer. But that number A needs to be a number between 1 and 10. So it could be 2.5. It can't be 0.3 because that's less than 1. It can't be 11 either because that's more than 10. And M is an integer. So the power of 10 has to be either a positive or a negative whole number. So for example, suppose we have a fairly big number, 248,000. So the point is we don't want to write so many zeros, we want to make it nice and easy to see how many zeros there are in our number. So what we do is, first we need to write the A value, the initial value. So right now we have the non-zeros are 248. So as a decimal we can go 2.48 times 10 to the power of what? Well, we start at the end of the number and we see how many times do we have to hop to get to 2.48. So 1, 2, 3, 4, 5. We hopped 5 times, so it will be 10 to the power of positive 5. Another example, suppose we have a relatively smaller number, 0.00307. So looking at the non-zeros, we have 307. So it's like sig figs where zeros squished in between do count. So what we want to do is turn that into 3.07. Not 30.7 because that'll be more than 10. Or not 0.3 because that's less than 1. So 3.07, that's our base number, times 10 to some power. So to figure out what the power is, how many times do we have to hop to the current decimal place to get to 3.07? So once, 2, 3 times. Now because it's getting a smaller number and we have to hop 3 times, then it's 10 to the power of negative 3. So for smaller numbers we make it a negative integer, whereas for big numbers we make it a positive integer. So example 1, let's write the following as scientific notation, and we want to round to 3 significant figures. So write as scientific notation and round to 3 sig figs. So let's look at 5218. 5218300. So we want to turn it into scientific notation first. So as a decimal, we wanted a number between 1 and 10. So let's make it 5.2183, the non-zero numbers. And then we need to multiply it by 10 to the something. Well, what is that something? How many times do we need to hop to get to 5.2? 1, 2, 3, 4, 5, 6. 6 times. So it will be times 10 to the power of 6. That's a scientific notation. Now remember, significant figures, the non-zero numbers count. So 5, 2, 1 count. We stop there. We look at its neighbor, it's 8. So we need to round the 1 up to a 2. So the answer will be 5.22 times 10 to the 6. Part B, 0.00423031. First, write it as scientific notation. So turn it into a number between 1 and 10. So it'll be 4.031. The 0 squished between the 2 and the 3 counts. Let's see how many times we need to hop. So 1, 2, 3. 3 times to get to 4.2. So what that means is times 10 to the negative 3, negative because it's a smaller number, it's 0 point something. That's in scientific notation. Now let's round to 3 sig figs. So 1, 2, 3, that's a third sig fig. Look at its neighbor, it's a 3, so we can keep the 0 the same. So our final answer would be 4.20 times 10 to the negative 3 as 3 sig figs. Now example 2, let's do it the other way around. Let's write as a basic numeral. Basic numeral. So for example, 5.016 times 10 to the 5, what is it as a big number? Well, let's do our decimal hopping. So 10 to the 5 means we need to hop our decimal place 5 times and make it a big number. So we're going to hop to the right hand side to make it big. 1, 2, 3, 4, 5. So we need to add in 2 more zeros after the 6 to make it full 5 places. So what we get is 501600 as our final answer. And then B, negative 3.2 times 10 to the negative 7. So the negative in front of 3.2, it's just a positive or negative number. You can leave it as is. This negative 10 to the negative 7 means we're going to make it a smaller number. So we need to hop to the left-hand side. So it's going to be 0 point something. So let's hop 7 times to the left. Oops, let's do red. So 1, 2, 3, 4, 5, 6, 7. So what that means is we have 0.1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 5, 6 zeros, and then a 3, 2. And then don't forget we had a negative in front, so then we can plonk a negative in front like that as well. So relevant exercises is exercise 3H. And then we have some complex familiar. Now don't forget, anything that has a word problem or some context, you need to have sentence conclusions and units if appropriate, but definitely sentence conclusion. Last column. Alright, that's it. Have fun.